A problem from complex number. Given that modulus of z minus 3i is less than or equal to 4, and we have to find out the maximum value of modulus of z minus 2 minus I. So to solve this problem, we should know that the triangular inequality in the complex numbers, that is modulus of z1 plus z2, is less than or equal to mod z1 plus mod z2. Okay, a basic inequality, we call it as triangular inequality. Modulus of z1 plus z2 is less than or equal to mod z1 plus mod z2. Now here see, modulus of z minus 3i is less than or equal to 4 is given. This is the only information given, and we have to find the maximum value of this modulus of z minus 2 minus I. So what we do is modulus of z minus 2 minus I is equals to, we adjust this because of we know that modulus of z minus 3i value is less than or equal to 4. So we adjust this modulus of z minus 3i in the required value, modulus of z minus 2 minus I. What I am going to do is, I'll let simply z, then I'll write minus 3i. Okay, so I added this 3 minus 3i. Now after that I have minus 2 minus I, and because of we subtracted 3i, we add 3i. Now we write modulus of z minus 3i together, that we know already, and plus the remaining complex number minus 2 plus 2i. Okay, I will separate it. Now you think of this is as one complex number and this one as another complex number. Like you can think this is z1 and z2. So according to this property, modulus of z1 plus z2 is less than or equal to mod z1 plus mod z2. Here you can separate the modulus z minus 3i, modulus of z1 plus modulus of z2 minus 2 plus 2i. But modulus of z minus 3i is already given that it is less than or equal to 4. So this is less than or equal to 4. And what is the modulus of this complex number? We know that modulus of a plus ib is root of a square plus b square. So here we have modulus of 2 minus 2 plus 2i. What is that? Root of real part square, that is minus 2 whole square, plus imaginary part square, that is 2 square. So finally we got modulus of z minus 2 minus I. We started with this modulus of z minus 2 minus I is less than or equal to 4 plus root of 4 plus 4, that is root 8. Nothing but modulus of z minus 2 minus I is less than or equal to 4 plus 2 root 2. Root 8 value is 2 root 2. So therefore maximum value of modulus of z minus 2 minus I is how much? 4 plus 2 root. Of course, you can solve this problem using geometrical approach. Okay, modulus of z minus 3i is less than or equal to 4. If you identify this is actually a circle, it represents a circle. If I take is equals to 4. So using concept of circle also you can solve this problem. Now here we have a problem from complex number. Let's say z is equal to 1 by 2 minus 2i is given, and the condition is modulus of z plus 1 is equals to alpha z plus beta of 1 plus I. Now substitute this z, whatever given the value of z, you substitute it. 1 by 2 minus 2i plus 1 is equal to alpha into z is 1 by 2 minus 2i plus beta into 1 plus I. Now once you observe that, here in left hand side, what you are seeing in left hand side, it's totally a modulus of a complex number. Modulus of a complex number actually is always real. This is always real. Real means imaginary part is 0. Okay, so right hand side also we should have imaginary part is 0. Okay, imaginary part should be 0. Imaginary part of right hand side should be 0 from right hand side. So what is the imaginary part you get? Minus 2 alpha I, that is minus 2 alpha. Again beta I, that is plus beta, should be 0, implies we got a relation between alpha and beta, which is beta is equals to 2 alpha. So just we got one relation between alpha and beta, that is beta is equals to 2 alpha, by comparing imaginary part. Because of left hand side is totally real number, purely real, imaginary part must be 0. I got it. Next, here if I substitute beta is equal to, now left hand side you check, 1 by 2 plus 1 is 3 by 2, 1 by 2 plus 1 is 3 by 2, minus 2i left hand side is equals to right hand side. We replace beta by 2 alpha. So multiply with this, alpha by 2 minus 2 alpha I, again plus beta is 2 alpha, so 2 alpha into 1 plus 2 alpha I. So it is cancelled. So alpha by 2 plus 2 alpha, which is 5 alpha by 2, which is equal to modulus of a complex number, root of what we get is 9 by 4 plus 4, which is 5 alpha by 2 is equals to, for 16 plus 9, 25, root of 25 is 5 by 2. 5 by 2, 5 by 2 cancelled, we get alpha is equal to 1. So because of beta is equals to 2 alpha, the relation we got, alpha value is 1, if you substitute you get beta is equals to 2. So we got alpha value is 1 and beta value is 2, and what is the value we want to find, alpha plus beta, so alpha plus beta is 3. Z is equal to root 3 by 2 plus I by 2 whole to the power of 5 plus root 3 by 2 minus I by 2 whole to the power of 5. So here this problem can be solved in 2 to 3 different ways. You can use binomial theorem, expand and simplify, you will get it. And one more way is, if you identify this root 3 by 2 plus I by 2, let's see, first I'll explain the basic of this. Let's say, you know what is omega? Omega generally cube roots of unity, which is minus 1 plus I root 3 by 2. This is omega, minus 1 by 2 plus I root 3 by 2. Now, if I multiply this omega with I omega is what? I omega is minus I plus I into I square minus 1, that is minus root 3 by 2 if you multiply with I, which is nothing but if I write minus common, if you take root 3 plus I by 2. So root 3 plus I by 2 is what? Minus I omega. Root 3 plus, what is that? Root 3 plus I by 2. Root 3 plus I by 2 is minus 2 omega. Minus I omega. So is equal to what? Minus I omega. Similarly, omega square. What is omega square? Minus 1 minus I root 3 by 2 is omega square. If I multiply with I omega square is what? Minus I into I square, so plus root 3 by 2, which is root 3 minus I by 2. So root 3 I by 2 is I omega square. So here you can see that this is root 3 minus I by 2 and this is root 3 plus I by 2. Correct? So root 3 plus I by 2, what I can do? Root 3 plus I by 2, I can replace by minus I omega, and the root 3 minus I by 2, I can replace it by I omega square. So what will happen now? So Z is equal to root 3 by 2 plus I by 2, nothing but what? Root 3 by 2 plus I by 2 is nothing but minus I omega to the power of 5. Then plus root 3 by 2 minus I by 2 is I omega square to the power of 5. So which is minus I power 5. What is I power 5? I power 5 is I power 4 into I. I power 4 is 1, we know that. So 1 into I is going to be I. So I omega power 5. You know omega cube is equals to 1. So omega power 5 is omega cube into omega square. So omega power 5 is omega square. We always remove 3's when you have highest powers to omega. So we get here omega square. Then plus I power 5 is again I. Omega power 10. What is omega power 10 again? Omega power 10, we have to remove all the 3 multiples. 3 3s are 9 gone. So we get omega. So I into omega. So which is nothing but if I take I common, I'll get omega minus omega square. So which is I into, what is omega value? Omega value here we have omega value minus 1 plus I root 3 by 2 minus omega square. Minus 1 minus I root 3 by 2. So to LCM we get I into minus 1 plus I root 3, okay, plus 1 plus I root 3 divided by 2. So here plus 1 minus 1 gone, which is 2 root 3 I, 2 is also gone. So root 3 I remains into I. So root 3 I square, which is minus root 3. So without using binomial theorem, just a simple observation that omega and omega square, if you multiply with I, you are getting this root 3 by 2 plus I by 2. And we know how to simplify omega powers. Okay. If z is equal to minus root 3, here you can see that real part of z is minus root 3, which is negative. Real part of z is negative. And what is imaginary part? There is no imaginary part in this. So imaginary part of z is 0. So real part of z is negative and imaginary part of z is 0.